All right. So now that I remember to click the record button, I'm going to do a quick lecture over all the stuff that we've got today that should have been covered on Monday, but since we were off, we didn't get a chance. And most of it is terminology, so don't sweat that too much. As for the lab, I made a mistake. It said Windows 7, so if you looked at it Monday through Wednesday, it said Windows 7 in here. If you got started on that lab already, then just keep going. Answer all the questions in Windows 7. If you're just looking at the lab today, then nothing changes. You're good. Just continue on, forge ahead. Two things, right? Windows 10, download that. That is big. That is the hugest thing. Make sure you can do that. If for some reason you can't do that, I've got a drive floating around here that I can give to you here in Abilene. Or if you're in Brownwood, just let me know, and I'll fix that link.
So instead of
There we go. We'll do that. All right. So let's go over the notes real fast. That'll be the main thing. And then we'll come back around. I want to show y'all how to actually install Windows. All right. So my notes are typically just a condensed version of what's in the book, as well as other things I think you might need to know. So most of the time you can get by just getting the notes, but I really do recommend that you read all the things. But I get it. Life gets in the way sometimes, and it's just not possible to do that, especially since I'm not your only class, right? There's 3 others that you're dealing with. So I totally get it. I understand. Just make sure that at the very least you're reading the notes. All right. So some things you got to know. Operating system. Hopefully you know the definition of that by now, but it's a little bit more in-depth than just the thing you use to run Chrome, right? Because I think that's what most people actually use an operating system for. If you go talk to anybody that's like, yeah, I do a lot of social media or whatever, I mean, they're doing it through Chrome, most likely. Does anybody use a browser that's not Chrome as your daily driver, as whatever you use most? Is it not Chrome? Do you use Firefox? Do you use Brave? What do you use? Firefox? Firefox? That's it? Everybody else uses Chrome? All right. So, and that's pretty representative, actually. Firefox and Edge and everything else are just a small subset of the bigger thing, which is Chrome eats up like 80% of the market. And about 80% of us in this class run Chrome. So yeah, it totally makes sense. So the operating system is more than just being able to run a browser, right? It deals with the CPU. It allows the CPU to run to its full potential. It deals with, think of the fact that you've got 2 or 4 or 8 or 16 cores on the CPU that you've got running in your laptop or your desktop. Your operating system has to manage that. So Chrome may be running on 4 or 5 or 6 of those cores. And then you got Firefox running over here. You got a game running in the background. You've got Notepad. You've got Word. You've got VirtualBox, right? For me, I've got OBS running back here as well. And it's managing other resources like RAM. So the idea of RAM, we'll get into it a little bit more, is just it's your working memory, right? Think of when you're doing a math problem in your head. You're not writing any of it down. You got 1 plus 2 plus 3 plus 4 plus 5. And you might be using your fingers, you might be, just thinking about it or whatever, but you're doing 1 plus 2, all right, that's 3, and then 3 plus 3, okay, that's 6, and then 6 plus 4, all right, that's 10, and you're working your way up, right? And for most of us, we can hold a lot of that in our head as we go along and work it out. That's RAM. That's what a computer is doing. That's how it's dealing with this, except it can remember a whole lot more than we can. It remembers all the things about Chrome. This becomes pretty apparent when you're running on a hard disk, on the spinning types. When you open up Chrome, so if you reboot your computer, right, a true reboot, shut the thing down, cold boot, and you drop into Windows, takes forever if you're on a spinning disk, right? And then you click on Chrome, takes a little bit, but you close Chrome and open it again, it's instant. instant the second time because that's RAM. Your operating system remembered how to do that before, so it didn't have to go reach to the disk and pull everything off and get everything added to memory again. It was already in memory. So you click on Chrome again, it's almost instant. Now, if you have an SSD, it's a lot harder to see because SSDs are really fast. They're not RAM fast, but they are really fast. And so you can get that illusion that, oh, it's always instant. Everything is always instant because it almost is. And then it deals with your disks, right? Storage. It's that reminder that tells you, hey, your storage is filling up. You probably want another disk, or you want to make this disk bigger, or something, right? It deals with all of that. That includes, and yes, DG Mac, it's for operating systems. This includes dealing with when you download a file, putting it in the downloads folder. When you install an application, dealing with where it puts all those files, whether that's in program files or program data or app data or in the C drive or in the D drive or whatever, right? Like, it doesn't matter. It doesn't matter at all. The operating system deals with that. And we're still just scratching the surface of what operating systems do. So it's an intro class, so I'm not going to kill you with it. But those are the big things. Those are the big overarching things. And Windows is not the only one. There are a couple of us in here that are running Mac, so they're dealing with Mac OS. And there are the extra niche guys like myself that tend to run Linux. And a lot of times, there's like a ton of flavors. It's like all the Skittles that are out there, right? I mean, there are more flavors of Linux than there are flavors of Skittles. And there's a lot of flavors of Skittles, right? There's the tropical kind, and the classic kind, and the minty kind. Yeah, right? You know what I mean? So there's tons. But Ubuntu is the big one. Like Chrome eats up the massive amount of market share for the browsers, Ubuntu eats up a massive amount of market share for the Linuxes. So it's the most popular to run on your desktop. So as far as what we're talking about, a desktop operating system, what you see, what you click on, all the graphics and all the fun stuff, that's Ubuntu. That's what you're going to see. If we get some time at the end of this, I'll boot up this Ubuntu box so you can see what that actually looks like. But it's different. It's different, right? It's not the Windows paradigm. It's not the little start menu at the bottom left. It's not the Mac paradigm either. It's not a dock at the bottom. They shove their stuff to the left. I don't know. They just had to be different, I guess. But anyway, so what I'm describing, Windows, Mac OS, Ubuntu, they're all multi-user operating systems. The idea with that is that you can have your account and your wife or girlfriend's account and your kid's account and a guest account and all this stuff, right? And the cool thing is, your wife can set something up to run. Like, let's say she's a video editor and she's doing a transcode of a video. She's changing the video from one format to another format. That takes a lot of CPU or GPU, graphics card, and time. So she can set that up, press go on that, and then lock the machine. And you can walk up to it, switch user, and log into yourself. So while she's doing stuff in the background, you know, she's not physically doing it, but she's set something up to run in the background, you popped open Chrome and now you're surfing the internet, watching Netflix or something like that. Multi-user, that's what that means. To have multiple users doing things on a machine at one time. CPUs are really cool in that it gives you the illusion that it's all happening at the exact same time. But just happens that things happen so fast you can't tell the difference, right? So single user operating systems are a little different. These operating systems are meant for one thing. Think of big machinery, right? Think of that Krispy Kreme donut thing, right? Where all it does is it sprays out the batter into the oil and that little lazy river floats it down, and then it does a little flip, and then lazy rivers all the way to the end, and then someone glazes it, right? All the things that the machine did was pre-programmed in there, and that's all this thing does. Can Krispy Kreme user 2 log into that machine? No, because all it does is flip donuts. That's what it does. It's a single user operating system, and that user is the machine itself. It is an appliance. So When you pop open your coffee maker and you can program it, it's still an operating system. It's still got to deal with hardware in a software-defined kind of way. So your coffee maker is a single-user operating system. It's not quite, but it fits the definition. So those are the big things. Then network operating systems are typically just extensions of this multi-user operating system idea. So multi-user operating systems are an older way, right? Unix. Back in the 70s and 80s when you logged into a machine, you did things locally. Or that mainframe was like down the hall in the gymnasium because it's so massive, right? This network operating system takes that same idea where multiple people can log in, and it just adds networking to the mix, where now you can hit the internet. Now you can do this or that or whatever. So network operating system, or NOS, is just multi-user operating system with networking. That's all it really is. So real-time operating system is an extension off of the single-user idea, and these are machinery. This is that Krispy Kreme thing. That is a more apt term for what's happening, or for the type of system that is. Embedded operating systems, another single-user operating system type idea, and this is more that coffee maker. It's that GPS system. It's the ATM. They do one thing, and it's logged in already, or it's only just one. You don't have to log out and log into it, right? It's already there. So an ATM, you walk up to it, you put your card into it, punch in your numbers, whatever you're going to do, and it spits out money, or it takes your money, or your check, or whatever it does, right? So it's an embedded operating system into that system. That's all it does. So the kernel. This is, as I've got there, it's the heart of the operating system. Without a kernel, none of the stuff that we've described works. None of it. The kernel is a middleman. So you can't just take hardware and random software like a video game. So you have a graphics card and a video game. You can't just smash those together and just hope for the best. That is not how that works. There is a middleman that deals with all of this. So graphics card don't speak software, and software doesn't speak graphics card. The kernel is the guy in between that translates for each. So when the operating system says, hey, we're about to launch this video game, and I'm going to need to make use of the graphics card. I'm going to need to make use of a ton of RAM. I'm going to need to be able to read off of the disk, and possibly, if we're updating, write to the disk, et cetera, et cetera, et cetera. Well, the operating system doesn't directly say that to the hardware. It says it to the kernel, and the kernel is just another piece of software. It says, hey, kernel, I'm going to need these things, right? Graphics card, hard drive, RAM, this, that, the other. The kernel takes software speak, translates it into hardware or firmware language, and says, hey, hard drive, we're about to need you. Hey, RAM, we're about to need about 6 gigabytes. Hey, graphics card, get ready, because here comes a stream of data that you're going to need to render, and then throw that out to the monitor. So that kernel, without it, the software couldn't speak to the hardware. You would have a non-functioning system. And in Linux, the kernel is really important. They talk about it all the time. There's literally a website for it. Kernel.org. Hey, there was an update today. Have fun. So this is the version of the kernel in Linux. And the cool thing about it is that you can use this one, which is like bleeding edge, emphasis on the bleeding, meaning it can break. This is probably the one you want to be running on. And these are the ones that have long-term support. But there are all kinds of version numbers. And you can use any of those. The difference in the kernel in Linux, as opposed to Windows, is that the kernel in Linux has all the drivers. It knows exactly how to speak to the hardware that you're telling it to talk to. That's built into the kernel itself. So the kernel in Linux is way more important than the kernel in Windows. You can't operate without either. So, I mean, you still need it. Still absolutely 100% necessary. But Windows deals with things a little differently. The kernel is still that language that bridges the divide there, but the idea of drivers in Windows exists, right? If you've ever bought a new piece of hardware and it didn't work out of the box, you had to install a driver for it. Maybe, I mean, this happens a lot less now because Windows has a massive driver repository and they'll just install it for you whenever you plug something in. But back in the Windows XP and Windows 7 days, this wasn't always the case. You installed something and then you went to Device Manager over here. We still have Device Manager. And it would tell you something like, hey, this new monitor that you got, there's a little yellow exclamation point on it. It's like, I don't know how to use this. So before you can use it, you're going to have to install a driver. So you'd have to, right-click on it. This would say install instead of update. And then you would go through and point it to the right file, and then it would add it. And then you can use that hardware now. Well, that works pretty seamlessly now. But the big difference is that drivers, or the essentially the code that allows the kernel to speak to the hardware, is not integrated into the Windows kernel. It is separate. So the idea of drivers is one in Windows, but is typically not one in Linux. Because every bit of that code that Linux needs to communicate with that hardware is built right in. It's in the kernel itself. So if you want new driver support, there's new hardware that came out and your kernel doesn't support it, what do? Just upgrade the kernel. That hardware is probably supported in, so like if you're on 5.4 right here, and you brought home the shiny new graphics card and it doesn't work, you need to get on 5.5. Good chance that card works in 5.5 instead. This actually happened to me. I was on 5.3. I bought a new Radeon 5700 XT, and everything was choppy. Like, no, that's not going to work. So what did I do? Upgraded to 5.4. So I went from 5.3 to 5.4, and all of a sudden, my graphics card works amazingly. Everything is nice and smooth. My monitor's running at 144 hertz. It's fantastic, right? I launch a game. It works. Fantastic. So, and that goes with anything, right? You bought the newest, latest, greatest USB card that has Thunderbolt support or something like that, and your kernel doesn't support it. You've got to get a newer kernel. That's the whole point that I'm trying to make here. And with Windows, you don't upgrade the kernel. Windows handles that for you in the background. You upgrade drivers. So if your card doesn't work, you go out to the internet and download a driver and install it in your system. So Linux takes a more automated approach, an all-in-one approach, and Windows takes a piecemeal approach. You get the kernel, but you don't have to care about it. And then you just integrate drivers as you need. There are pros and cons to both. But that's beyond the scope of today's lecture. So we'll get into that a little bit later once we hit the Linux class. RAM. I mentioned this before. It's the computer's working memory. You launch a program, it will remember that. You close that program, open it up again, it's instant. And a lot of times it'll even remember where you left off, right? And that's all stored in RAM. So the thing about RAM, though, is it's not permanent. The moment you reboot, RAM is emptied out. Garbage is taken out. It's all empty. So when you do that's what I was talking about, when you do a cold boot, the computer was fully shut down. You press power, it starts up Windows, you get into the desktop. That's a cold boot. You try to launch something, it's going to take a little bit because it's got to read all that information off the disk, put it into RAM, give it to the CPU, and then launch it, and then actually run the thing. So if it's already in RAM, you skip that step of storage, of reading it from the hard disk or the SSD. So it's slightly faster. And everything you do is in RAM. Everything. Except for what you type. But, the funny thing about that is that it's still in the CPU, whatever it is that you type. And this RAM and CPU exploits, we're getting to the point now, and we'll talk about this more as we get into the security side of the operating system in a couple of weeks. But we're getting to the point now where it's really... It's dangerous. Like it's more dangerous than it was in the 90s, back in dial-up days when you were just directly connected to the internet. I mean, it's still that dangerous, and for the same reasons that it was dangerous back in the 90s. Like we like to think that operating systems have gotten a lot smarter. In a lot of ways, in some ways it has, but in a lot of ways, operating systems are more vulnerable now than they ever were back in the day, ever. I mean, the students that come in, if you guys hang out and actually watch some of this spiel, you're going to see what I'm talking about. We have an exploit that's running over there on two virtual machines. One is running Windows Server 2008, and all we did, installed Server 2008, got all the updates, shared a folder. That way, in the enterprise, this would be Hi, I'm John. I just got hired. I need to get access to the Excel spreadsheets that we do our accounting on so I can, do my job, right? So we just shared that folder. The act of doing that makes Windows 2008 revision 2 susceptible to remote code execution. That phrase doesn't mean anything to you yet. Remote code execution is basically the way that we, as a hacker or someone that is trying to be malicious, can run code on your computer. And that still might not make sense to you yet. But run code means, like when you double click on Firefox and it runs, that's running code, running a binary. So if that binary was ransomware, well, now all your files are encrypted and I have the key. I'm the only one that has a key to it. Now all you've got is a Bitcoin address to send me 3 Bitcoin so I can give you the key, and now you can unencrypt your stuff. That simple idea, I don't know, depending on how you look at it, for the past 3 years has been the most dangerous idea in if you're running an enterprise. This is what has knocked over hospitals in the UK. I think I may have mentioned that to y'all. I remember who I mentioned it to, but knocked over multiple hospitals in the UK. It is. That's exactly what this is. It's ransomware. And it's knocked over a few municipalities here in Texas, right? And then, I don't know, for whatever reason it might be, nobody had good backups. So they just paid the ransom. So if you pay the ransom, it encourages people to do it more. And guess what? It's still happening. So, yeah. Doesn't matter. If you get 10, at least somebody's going to pay the ransom. One guy will pay the ransom. So, anyway, RAM, there are exploits like Rowhammer that essentially allow you to extract information from RAM. And when you add the password database, every computer has a password database, whether that's remote or local. Some computer has your password hash, not the password, but a password hash. We'll talk about more of that in cryptography, but it'll store the hash that represents your password in memory. And with exploits like Rowhammer, you can strip that out, have it locally, and then just beat away at it until you figure out what the password is. It works great when your password database is online because you can't really beat at it very fast. But when you have it right there locally on your hard disk, man, the sky's the limit. It's just however fast your computer can run, that's how fast it'll go through trying every possible password. And eventually it'll find the right one. So, and then with CPU, we have exploits like, what is it? Zombie load is, we've seen way more than about 20 or 30 exploits come out in the past since 2017, CPU exploits. Now, how do you update your CPU? Exactly. That's the point. That's why people are so susceptible to things like this. Because, and the real answer to that question is, you don't. If your CPU comes with an exploit baked into it, you didn't know it at the time, Intel didn't know it, you didn't know it, you bought it, plays your games okay, whatever, fine, right? But it's shipped with one. It's discovered 2 years after you bought it. And now you're in this situation where you've got a CPU that is susceptible to exploitation. So you've got these things that, as we were talking about with RAM, you can strip stuff out. You can literally siphon off the stream of what's going into the CPU. So you still let the CPU do its thing so, poor soul doesn't actually know what's going on. And you siphon that off as well. So you basically just tap it, same as you would a phone call. You just tap it, and that stream goes into your, what do you call it? Like you call it something like a Stream Explorer, but it's basically just all the code that's going through the CPU. You just log it. You feed that into something that can read CPU code, and out pops usable data. And what if your CPU was processing a password? Whoops. There it is in clear text. So, and these are hardware exploits. There's no amount of solder that's going to fix this. And Intel is just up a creek. The best we can do is turn off CPU features in software, in the operating system. So the operating system asks the CPU nicely, hey, just don't do this thing. Well, what's funny about that is that hyperthreading, a thing you'll talk about in PC hardware, is one of the mainstays of Intel's power strategy. right? They can squeeze out 20 to 30% more performance out of a CPU by running hyperthreading, right? This is just running the CPU in overdrive, basically. And that is the exploit. The hyperthreading thing is the exploit. So the fix for Intel CPU flaws is reducing the speed of your CPU by about 30%. Ouch. And then it turns out another exploit came out that doesn't require hyperthreading, so even doing that is a moot point. So anyhow, we're going to get into a lot of that a lot more. So let me just finish off on these notes so I can show you how to install Windows. So virtual memory. Just like we have a finite amount of brain power to do that 1 plus 2 plus 3 plus 4 plus 5, right? Once you get to like plus 20, you're like, I got to write this down. I actually have to write this down, otherwise I'm going to forget numbers or something like that. RAM is susceptible to the same thing. It can't remember everything, right? You got 8 gigs of RAM and your hard drive has 1 terabyte of storage. There's no way you can fit all that in RAM. So if you need to put more than 8 gigs in this scenario into RAM, you're going to have to utilize virtual memory as well. Virtual memory is just fake RAM, but on your disk. Now, if you remember back, after a cold boot, the disk was the reason that it was so slow opening up applications. Yeah. You don't want to be using virtual memory. It's a release valve. It's an overflow. If you're on an SSD, it doesn't hurt so bad because SSDs are really fast. But if you're on a hard disk, man, when you're in IT and someone gives you a call and they say, this is running slow, it's because they have too much crap open. Too much stuff is in RAM. It's overflowing into virtual memory. And when you're swapping between apps you haven't used in a long time, so things that are old in RAM get pushed out to virtual memory, and then you open that program up again, it's slow. It's going to be slow. So that's what virtual memory is. We talked about drivers already, right? Windows puts drivers off to the side. They don't add it directly to the kernel. Process. This is, it's easy just to show you. So this is an overview. It's actually not fine-grained enough, but if you go down to details, you can see processes. This is all the stuff that's running on my computer right now. And I really dislike the way that Windows obfuscates everything from you. SVC host, SVC host, SVC host, SVC host. Service host. That refers to these things. So notice that one is running. Let's just do the status running. So this. Blah, 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 right? There are about as many SVC hosts in details over here as there are services running. That's what SVC host is about. It's just these things that are running in the background, right? This one is the one you're going to get used to the most because anytime someone calls up your phone and says, my computer's running slow, I bet you money this is why. Trusted installer. So trusted installer is basically the way that Windows installs updates. So if someone's computer's running slow, check and see if it's trusted installer that's taking up all the, sucking up all the oxygen in the room, because it's probably just installing updates in the background. And that's why it's running slightly slower than it normally would. But sometimes it's just you got 700 Chrome tabs open and you ran out of RAM. Like, that happens too. Yeah, so when you're going in and doing diagnostics like this, there's not a one-size-fits-all solution. You have to know what to look for, and we'll talk about that, and then make informed decisions, right? Think about, and by no means am I saying that what we're getting out of here is a master's or a PhD in biology or anything like that, but it's kind of like the doctor's office, right? The doctor can't just look into your eyeballs and tell you, oh yeah, well you got the flu, right? You got to go in there and be like, man, my neck is hurting, my back is hurting, I have a fever, I'm sweating, I don't know what's going on. And then he's like, well, all these symptoms kind of indicate that you've got the flu. Let's run a test on that and find out. And then the test comes back positive for the flu. Bro, you got the flu. Go drink some orange juice and get a lot of sleep, right? We got to do the same thing. We've got to take a look at the symptoms that the computer is experiencing and make informed decisions about that. There are tests that we can run, right? There are benchmarks that we can run. If we have a baseline, if we know what a healthy computer looks like, and then we run the benchmark again, and see what a sick computer looks like, we're like, all right, well, it looks like this process is using way more CPU than it was before. Let's look at what this process is doing and why it's taking up so much CPU. So anyway, we're going to delve pretty far into processes. A software patch. If you ever see patch, it's just another name for update. So if someone says patch your system, they're telling you to update. There is a phrase that you're going to hear quite a bit. Once you get into the when you take the filter off a bunch of admins, you're gonna hear things. And patch your S, fill in the blanks. That's it, right? What we've got in the overarching IT world, we've got ourselves into a situation where a lot of the exploits are coming directly from software that we're running on our computers. Chrome and Firefox and browsers in general being the biggest attack surface. That's why in Windows, and I'm not a fan of this style of software management, but in Windows, you go to the website, you download an executable, you double click on it, it installs, and then like it runs, right? How do you update software? How do you actually do it? That whole same process again, right? Your software's like, hey, there's an update. Click on this link to go download the new thing. So you download the new thing, you double click on the executable, you click next, and it installs over the top of the other one, and now you're on the new version, right? How many people do you think actually do that and keep up with all the software that's on their computers? Yeah, exactly, like 5%. People that are paranoid like me, right? That's it. That's why Firefox and Chrome integrated in an actual updater inside of them. Provided you close your browser on occasion, it will update every single time. Unless the updater fails, in which case you got to go fix that. But the idea is that as long as you close it, it'll update. But especially people on Macs have this habit of just closing the lid and never thinking about it. Well, if you don't close Chrome, it doesn't ever restart. And if it doesn't ever restart, it doesn't ever update. And if it doesn't ever update, you are susceptible to various creepy crawlies on the internet. So, patch your stuff. We'll say stuff. Service Pack, it's a dead word. Windows 7 end of life last week. So, Service Pack is pretty much a dead word. But we still got to talk about it because guess what? How many people at the end of life, it was January 14th, how many people do you think clamored for Windows 10? How many people that were actually running on Windows 7 on that laptop right then and there were like, oh no, it's January 14th, Windows 7 is end of life, let's go upgrade to Windows 10 because that's the responsible thing to do. How many people in this world do you think did it on January 14th? My guess would be 0. Nobody cares. Nobody cares. Nobody. And it's a sad fact, right? Because a Windows tool. Nobody looks at a hammer and is like, how do I update this thing? Nobody. People that look at Windows 7 look the same way at that they do at a hammer. It launches Chrome for me. I log into Facebook. I chat with grandma, and that's how that works, right? Nobody thinks about the underlying stuff. This is going to be your job. It is your job to think about this stuff for the people that don't give two craps about it, right? That's why they hire you to handle 100 computers, because nobody comes in at 8 o'clock and is like, let's see how responsible I can be and run my updates before I get my work done. No, they're like, I'm here to get my work done. So that's your job now. So Service Pack should mean something to you. And if your company is crazy enough to be running Windows 7 now, you need to be on Service Pack 1. Service Pack to Windows was basically two things. It was a bunch of updates, like a ton of them. And it was a new contract between you and Microsoft. Every time Microsoft issued a new Service Pack, they issued a new end-of-life date. So Windows 7 without Service Pack 1, end-of-lifed like years ago, years and years ago. But Service Pack 1, end-of-lifed January 14th of this year. So that was what that was. We do not have Service Packs anymore. We had something close to it with Windows 8. Y'all remember, I don't know if y'all remember during the release of Windows 8, everybody hated it. It was like, they changed my start menu and people's heads exploded. And it's like, just search for stuff. Man, look, I showed you guys this before. Like, Just search for things. Just because it went full screen doesn't mean it. Anyway, whatever. You're getting off on a rant now. But in 8.1, which would have typically been a service pack, but Windows isn't trying to get into that legal argument anymore. They're just throwing away that word. Windows 8.1 acted as a service pack and added some features to the thing. Now you can have just a small menu like you do in Windows 10, and you don't have to be full screen or whatever the deal may be. And Microsoft didn't have a new legal agreement behind it. They threw away the service pack name because they didn't want to be legally bound by anything. Well, at least in that case. Now with Windows 10, service packs are 100% gone. There is no Windows 10.1. There's no Windows 10.2. What is there? What have you guys seen so far with Windows 10? Do y'all know? Have y'all seen it? How long have y'all been running on Windows 10? More than a year? You've seen one of these, but you may not have paid attention to it. They're called feature updates. So we go from 15.11 to 16.07 to 17.01, 3, something like that. Funnily enough, those numbers actually mean something. 15.11 is 2015, the year, 11, the month. November of 2015 is when that patch was available, generally available. It may not have come to you until December or January because they do a slow trickle rollout, but that's when it's minted. That pack is, or that feature pack is minted 2015 November. And so our newest one, 1903, well, it's 1909. Yeah. So the newest one, 1909, when was that one minted? 1909. September 2019. Perfect. Yep. So, and actually this desktop didn't get it until December. So it's that slow rollout, right? They're not trying to screw everybody at the same time. Just small groups of people every now and then, right? That's the deal. So Service Pack is what it used to be called. It was a point release during Windows 8, and now it's a feature update now in Windows 10. And that becomes pretty relevant because I can't show you guys, well, I can, but to be a responsible person that's telling you about Windows, I'm not going to have you do Windows 7, though, as I mentioned the mistake earlier. If you're doing Windows 7, that's fine. Anyway, updates come in a few different forms. This is not like hard data. This is not what every company is going to call it, but these are some general words that you can use when you're referring to types of updates, right? Compliance updates. These are adding privacy features, staying compliant with things like FERPA and HIPAA. You might not know FERPA. You should. You might not know FERPA, but you know HIPAA, right? Every time you go to the hospital. It's actually not necessarily for the hospitals, for the insurance companies, so they can't sell your data, right? HIPAA does that, and you can't share it without strict consent, right? Same with FERPA. So we're bound by very similar rules that hospitals are bound by, but for your school stuff. I can't just go tell anybody about your grades, right? They have to sign a piece of paper. Like, not even your wife. Like, you got to sign a piece of paper. And then I can tell somebody about your stuff because it's protected. It's privileged information. So updates that an operating system goes through that force you to be compliant with something, those will fall under compliance. Whoa! Efficiency, right? Well, the operating system was running slow. Now that I applied this patch, it's running faster now. Efficiency. And then security. As I was mentioning, you've got, oh yeah, these are really good ones. If you guys Google these things, I love it. Like, these are fantastic. These are the ones that will scare the pants off you. Scare the pants off all the admins that make their paycheck off of making sure that the data is secure on their servers, right? Scares the pants off those people. So this is the kind of stuff that you want to be looking into if you're into security, if you want to be someone's security later on. Read up on these.
That's the British one, right?
Yes, that started over there, but almost everybody that was running Windows 7 directly on the internet got hit by this. It was insane. WannaCry was massive. So Heartbleed was a way to siphon off data off of Linux servers, privileged data, right? Passwords, things like that, databases. Ooh, crazy stuff. WannaCry was the ransomware that got spread around a couple of years ago in 2017. Started out, well, the big news story was out of the UK, took out a bunch of the hospitals that were in the NHS, right? Like, well, all hospitals are in the NHS over there. But it was like 3 hospitals, and they had to like reroute patients. It was crazy. And then Stagefright, same kind of idea, but on Android. Ooh, siphon data off of an Android phone, right? You didn't have to do anything special for this. You didn't have to root your right? Everybody tells you, oh, don't root your phone. It makes it more vulnerable. It does, but Stagefright didn't require that. And they were able to steal information off of your phone. Like, these are fantastic, fantastic exploits. And I know it seems like I'm being flippant about it, but I mean, these are devastating things. These kinds of exploits can take a company and turn them into dust, right? These are the Thanos snap of exploits. These are bad ones. So if you want to learn about this stuff, read about these. The starting with Heartbleed, and there was another one called Dirty Cow that affected Linux. Starting with about those two, for some reason, exploits are getting funny names. And they're getting really cool logos. I don't know what this is about. It's all about marketing, I guess. I don't know why. But I think it's the emergence of the acceptance of hackers. Right? Back in the 90s, hackers were all criminals. Doesn't matter how you did it. Doesn't matter what you did. Doesn't matter how you touched it. Doesn't matter. If you looked at it wrong, you're a hacker. You're a hacker, you're going to jail for 10 years. Right? Like, and it's a federal offense. You'll never get a job. Like, blah, 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 blah. Now, we're paying them. Yes! I mean, in very rare cases, you get caught up as a black hat hacker, as someone doing malicious things, and in very rare cases, the federal government will hire you, right? I mean, the rest of them go to jail, which is kind of sad, but still, I mean, look at the big brain on Brad, like that guy just went to jail. It's sad, but we're running into issues, still legal issues about hacking and things like that, but perception is changing about this, and I think that's why we're getting so much play. We're getting logos, we're getting names, we're getting recognition. People that the guy that or the group that came up with Heartbleed, they got paid. It's fantastic. Instead of getting thrown in jail, because 10 years ago they'd have been thrown in jail, right? You leak your exploit on the internet because you're a good person, and then you scrub your name away from it, right? 10 years ago. Now your name is in blinking lights, and it's like, I did this. Microsoft Azure, one of the third biggest cloud provider on the internet, has $1 million bounty. $1 million bounty on VM escapes. So that the box that you're running in VirtualBox, if you can get code in one box to affect code in another box, they'll pay you $1 million. $1 million, man. So respect is changing. Anyhow, not too fast, because in Iowa, back in September, you had 2 guys that were doing a penetration test on the courthouse in Dallas County, Iowa, not Dallas County, Texas, Dallas County, Iowa. And so they were paid to do a penetration test in that. So it was to get into the courtroom. And when they got there, they opened the door, courtroom opened. What? All right, so really bad OPSEC in the first place, right? Like, somebody did not lock the door, right? Well, so they thought, well, they paid us to get in. So they locked the door, armed the alarm, closed the door. Broke the lock, got in, set off the alarm intentionally, and deputies came. Obviously, right? The alarm went off. Cops are coming. So deputies came and were grateful for what they had done, right? Like, thanks, showed me how to break the lock, showed me that the alarm works, showed all of this stuff, right? Here's how you get in, here's how you protect that kind of stuff. That's what a penetration test is about, right? Then the sheriff came. Showed the documentation, this is in scope, this is what we're doing, whatever. They went to jail anyway. So, that's scary, right? Because they were working for a company called, like Coalfire or something like that. They're a penetration testing group. That's what they do. It was a vaguely defined scope. So, yeah, they got put in jail for that. I imagine they'll be not acquitted. What is it? The charges will be dropped. But I mean, they were facing two felony counts, one of burglary and one of possession of burglary tools, 2 felonies, And they were just doing their job in security, right? Talked to the DA. DA dropped it down to misdemeanor trespassing. It's still on your record, though, right? And so they haven't gone to court yet, as far as I know. So I assume these charges will be dropped because I don't know how you can enforce trespassing when you literally had a paper that said that you were authorized to be there. So whatever. I don't know how they're going to argue that. But either way, hopefully those charges get dropped and those guys just go about their daily lives. But they spent a couple of weeks in jail. Not cool. But perception's changing. It's just not there yet. So anyway, lab time. I got about 12 minutes. But the big thing is that we start a new VM. So I've got information in here telling you how to set it up. This is the absolute bare minimum. 30 gig disk, 1 gig RAM, 2 virtual CPUs. That's the minimum. If you can afford to give it more, right? If you got a quad-core CPU, give it 3. Sure, that'll make it run faster. You got more than 4 to 8 gigs of RAM, give the VM 2 gigs of RAM or 4 gigs of RAM. Give it more. The more the better. And 30 gig hard disk. You got room to spare? Give it 40 or 50. It'll just give you room to grow. So we're going to try and follow those rules. It says 1 gig of RAM, so I'm going to give it 2. 2048 megabytes. So 1 gig is 1,000 megs. So if you want 2 gigs, it's how many megs? How many? 2,000. Yep. And if you do the actual binary math, it's 2048, but 2,000 is totally acceptable. And by default, it says 50 gigs. So, if you can afford it, leave it there. Leave it at dynamically allocated. That'll make the VM come up a lot faster. Do not change this. So these next two options, hard disk type and dynamically allocated, just leave them alone. We'll talk a bit more about what they are and why you want to leave them alone a little later. But in the interest of time, and this is just verifying your hard disk info, right? You said earlier you wanted a 50 gigs, so they smack that number right there in that box. And then it's telling you where you want to store that disk. So if you've got an external hard drive that you want to store your VMs on, now's the time to tell it. Click on this little folder, go into your disk down here, create a VMs folder and click OK, right? You can do that. Or leave it alone. By default, it'll just install in your user profile, in your home folder. Hit create on that. To do CPUs, you can't do that during that initial setup. Go to settings. So right click on this guy, go to settings, or highlight him and go to settings up here. Either or, take you to the same spot. Under system, the processor tab. So in the motherboard tab, if you want to give it more RAM or whatever, you can. In the processor tab, you can give it more CPUs. Never, ever, ever, for hyper-threading reasons that we'll get into later, go into the red zone. It will be slower than if you don't, I promise. Even one CPU is better than going into the red zone. So 2 CPUs is what I have in there. Here's how you do that. Hit OK. And then we can run this bad boy. First question it's going to ask you, y'all haven't done any of this before. So the first question that it's going to ask you is, give me a startup disk. Right? Because right now what we did was we pulled a computer off the shelf. Has nothing on it. The disk is empty. There's nothing stored on it. It doesn't have any memory other than what we've assigned it, but that's blank as well, right? Because it's off. I'm air quoting here for those of you that can't see me. So we need to give it a boot disk. If you've ever installed Windows yourself, you either had a DVD or a flash drive, popped it in the laptop and booted it up. We're doing the same idea. That file right here, Windows 10, that you download, that's the file that I'm talking about right here. This is what you want to give VirtualBox when it's asking for this startup disk. If you don't do it, you're going to end up in a situation. So what you would normally do is click on that little thing, add a disk, find your disk, wherever that is. In my case, it's right here, Windows 10 Enterprise 1903. That's what y'all are going to download when you click that link. Or I'll pass the drive around and y'all can see it. But some of y'all don't listen. So I'm going to show you what happens when you don't listen. So If you don't select it in that box, or for some reason you just accidentally click the X button, that box is never coming back. It only shows up one time. So if for some reason you're like, oh no, I clicked this box and it's not there anymore, it's going to come up and it's going to say this. And the reason that I'm saying that y'all don't listen is I guarantee you're going to ask me this question. I guarantee it. If you see this thing, you're going to ask me about it. You're not going to watch the video and see what I say about it. You're going to ask me about it. And it's fine. It's fine. Totally cool. I promise. It really is fine. But this says fatal. No bootable medium found. System halted. Right? There wasn't anything installed on it before, so it didn't magically get stuff now. So it's telling you, I can't boot. I got no way to boot. There's no boot information. So what you got to do at this point, so again, if you skipped that box earlier that I was showing you, you're at this point. Look down here. That little circle, that is a CD. Depending on how young you are, you might not know what that looks like. It is a circle. Right-click on this guy and choose a disk image. And that takes you, this should look familiar, right? We saw this a second ago. Click Add, find your Windows disk. Cool. Now it's in the list. Choose it. Nothing happens. Yeah, because you got to reboot. So come to Machine, go to Reset. And now we can watch the magic happen. Ta-da! All right. You're either going to do it right the first time and get it in that box and get it working, and you'll see this immediately. Or you'll see the fatal no bootable medium found, and you'll have to go through that process I just went through to insert the ISO image. These ISO images, just keep in mind, this is like if you put an operating system on a flash drive, plugged it into a computer, and let that computer boot. That's exactly what an ISO image is doing. It's got all the operating system files in it. So this should only take a couple of minutes. So this is probably the hardest part of it. So obviously English, I think you're okay. Install now. There's nothing to repair, so that's not going to be useful for us. Install now. Wait. And remember, if you guys are on a spinning disk, please remember, it's going to be a little slow. Spinning disks already have trouble running the operating system that they're running. And then you're asking it to run another operating system on top of that. So, and this was with an SSD. So it takes a little bit. Don't be alarmed if it takes some time. All right, so accept the license term, something, firstborn, something, right? Next. Custom. I can count on my hands the amount of times that I clicked the upgrade button in my entire career. The whole thing. And long story short, just don't. It's not worth it. I promise you. Whatever you're upgrading from, something's going to break. Just install Windows from scratch. And that'll be this custom option down here. You get that disk, that 50 gig disk that we created earlier, right? Don't even worry about it. Click Next. Make sure it's selected, but click Next. And then Windows starts installing. That was the hardest part. Seem pretty simple? Yeah. Okay. So that's pretty much going to be it. I'll leave this going. I won't record it, but honestly, I'll just leave it going until people show up. So this will take a little while. It's copying files from the CD or the ISO image that you gave it to the virtual disk that the virtual machine has, that 50 gig disk that we created. Copying from one to the other. So this part, the getting files ready, that's going to be the longest part. It's probably going to reboot a couple of times while it does this. You will see press any key to boot from CD or DVD. Don't press any key. It will boot you straight back into the installer, and then it will ask you to install Windows again. You've obviously already gone through the process where you're installing Windows, so you don't need to do that again. So if you find yourself in that situation, just restart the machine like we did before. Machine, reset. After the install is done, it's going to reboot you again, and then it's going to drop you down to that Cortana window. When you bought your laptop and you opened it up for the first time, Cortana started yelling at you, didn't she? You're going to get to that page as soon as this process is done. You don't have to do anything for it. It'll just happen once this is done. I don't think Cortana yells at you anymore. You don't have to mute her anymore. But I'm not too concerned about the choices that you make during that initial setup. I don't condone next in any case, even if you've done it 20 times in a row. Read it. Read what it says on the screen. The difference between someone that calls you every single time any little thing goes wrong and you should be that you read the screen, right? If you've ever dealt with someone that describes themselves as technically inept or I'm not good with computers, they don't read the screen. And granted, to their credit, they wouldn't know what it meant even if they did read it, right? You, by the end of all of this, will read the screen and will know what those things mean, or at least have an idea of where to go to figure stuff out. I promise. That one skill, that's it. That one skill is what's going to sign your paycheck. It's not big, huge, overarching engineering projects, though when you get the engineering title, that does become what you do. But in your first couple of tiers, your first couple of years of working as an IT guy, if you read the screen, you're already better than just about everybody else. Read it. I promise. The little toggles that you're going to encounter, it's like, do you want us to track every website that you go to so that we can give you some, customized ads? Do you want that or do you not? If you don't read it, you can't make a decision. You just let Windows decide for you. And the decision is obviously, yeah, we're going to track you. Yeah, we're going to use that to make money. Of course. So if you just next through it, you have no clue what you're agreeing to. Read the stuff. I harp on it a lot, but it really is important. Ooh, we might actually get all the way through this install before people show up. So hang tight. Ooh-wee. It's almost there. Almost there. There we go. Slowing down now, installing features, installing updates. Windows doesn't actually reach out to the internet and grab updates, so I never actually figured out what that line meant. If they ship the updates on the disk, why not just integrate them into the install? Yes, sir. Yeah, our thing a little later should be from like 11 to 11:45 or something like that. So that'll be good. Yeah. I should. I don't know when I'm gonna take a lunch, but it'll probably be around. I'll probably be back around 1:30, something like that. All right, so finished up here. Restarting. I'm gonna force it so I don't have to wait 5 more seconds. And this is what I'm talking about. Do not press a button when it says that. Don't do it. Don't you do it. You're going to want to, because we just have this habit of telling the computer okay to everything that it tells me, right? So do you want me to install a virus on your computer? Okay, right? Who reads the screen? Nobody, but you do. Now you do. Or you should anyway. And you know these people that bring computers in? I used to work at a computer shop, did that for about 4 years, and nobody ever knows how they got that virus on their computer. Nobody ever knows. And at first, I thought they were lying to me. At first, I really thought they were just pulling my leg and they were just trying to save face and, not be embarrassed about installing a virus on their computer. But then I realized it's true. They really don't know. They don't read the screen. They just let things happen. And Windows has this habit of presenting you with a yes or no option. Nobody reads that screen. They just say yes. The reason they say yes is because when I click yes, things work. It's not any deeper than that. It's not some conversation between them and their internal monologue, weighing the pros and the cons of clicking yes and clicking no, and they just made the wrong decision. It is not that deep. It is yes makes the thing go. Press yes. And they press yes. But they didn't realize that pressing yes was an infected PDF that started emailing every single person in their contacts list, sale links for whatever, right? Here's the link to Chase Bank. Yeah, it's I hacked you chase.com, something like that, right? Like, that's where the link led you to. So it happens, and there's no use. But that's the thing, right? Like, you got to grow a little bit, and I did in that situation where I used to think people were, I don't know, I mean, and it's going to be a little derogatory, but I used to think people were dumb because they didn't do this, right? Because they didn't read the screen. But the analogy I made before, it's a hammer to these people. You don't update hammers. You just use a hammer because a hammer does what it does. And they see computers the same way. Hammer drives nail. Yes makes it go. That's the thought process. So it's not that they're dumb, but it is that they don't care. But not caring is not necessarily a bad thing. The onus is now on Microsoft to handle this, to deal with the fact that people will just press yes. And they have. And the thing that we complain about all the time, if you defer your updates on Windows 10 for like a month, what happens? It just does it for you, right? It just forces those updates on you and you're like, oh my God, I was in the middle of this thing and it just randomly rebooted me. It didn't randomly reboot you, dude. You were clicking no for like a month and a half and Windows is just like, I had enough of this. We're doing it. So, yeah, that is protection for the people that just blindly click yes. It's almost there. I can feel it. I can feel it. And I know it probably feels like I get on the soapbox all the time because this is not the last time I'm going to do this. I promise you that. But it's things that it's not part of the class, right? Like, no book's going to tell you this stuff. No book's going to tell you how people treat computers. This is just I dealt with people for 8.5 years at various different jobs, and this is just how they see it. And you have to be okay with that. You can't change them. No amount of training is going to convince someone that they want to run their updates. And when we get to security class, we'll talk about security policy and how you don't piss people off. Because when you do that, they're going to just work around you, right? Like, you put 17 passwords in front of them and what they need to get done. They're going to figure out a way to do that 14. They're going to figure out a way to do 14 passwords. They're going to figure out a way. These people aren't hackers, but man, they just want to get their work done. And if you're a roadblock to them, they're going to go around you. And that's unfortunate because as security guys, you've got to be talking to people. You've got to be in their face, not in a bad way, but you got to be talking to them and understanding what they're trying to do, and it's your job to make it easy on them, not easy on you. But I think there's room for both. Okay, I said it was almost done a little while ago. It's almost done. I feel it. If I keep saying it's almost done, eventually I'll have it right. Yay! Okay, so I was right the second time. Cool. All right, so, these questions are pretty self-explanatory, I think. Yes, for the United States, unless you plan on traveling abroad and staying there for a long time. Because a lot of what that's doing is it's setting up the keyboard for you. There you go. So setting up the language, and this is setting up the keyboard. And you can skip this. You only have one keyboard, right? Your laptop. So skip that. You don't need extras. Important setup. Will. Yes, sir. You're in my recording again. All right, so this is the thing that I think is going to cause some issues. You do not have to sign in with an account. You do not. So I know it might be counterintuitive, especially when you learn what a domain is, but click this, and it will let you create a local-only account. That way, you don't have to tie it to an email. It's not gonna email you when you're trying to restore it or anything like that. And then just hit next. You really should set up a password, just so you get into the habit of typing one in every single time. But I think most of you guys do that already. If you skip this, it'll just make the process a little faster. If you set a password, it's going to make you set up those questions. What's your mother's maiden name? What was the first make and model of your car, right? So if you want, I'm going to show you how to do it anyway, how to set up a password later. So if you want, you can just leave this as no password. And if you open up the start menu here and just type in password, change your password, right? So you can just do that. Oops. You can just do that when you get fully logged in. So activity history, do you want that on or off? I'll leave it on. You do not have to. You do not have to mirror my choices on these questions here. I don't want Cortana. No, thank you. I don't need her talking to me. And I don't need to talk to her. And then this stuff, right? I'm turning a lot of this off because I'm running in a VM anyway. It is okay to leave it all on. It is not that big of a deal. Except that it just disables a couple of services, so it'll affect boot time a little bit. If you're not worried about it, then again, just leave them on. But at this point, we are pretty much done. It should drop me. It might reboot me, but it should drop me directly into Windows at this point. So I will leave that for just a minute. All right. We're there. All right. So this is the last thing that I'll get on my soapbox for. The first time you log into a new user account or get access to a new network or something like that, it's going to ask you this question. And again, if you just click yes, like we're trained to do, then you are exposing yourself to exploits that you may or may not want to be exposing yourself to. So the correct answer to this question here is no, unless you are at home. But if you got about 7 roommates, then the answer is still no. So just click no unless you know why you want to click yes. And that should be the default, I think, for all of these questions. Click no or cancel unless you know the reason why you're clicking yes or okay. That'll save you so much heartache. So I'm going to do no there. Basically what that's doing is basically turning on the firewall to its most strict mode, where people can't see your laptop on the network, or at least marginally, and they certainly can't throw attacks at you. That's the big deal. That's why you want to choose no there. Choosing yes opens up file sharing, opens up UPnP, opens up DLNA, allows a bunch of different protocols that allow you to reach out to the network and to the internet to do various things. But no does not prevent you from going to Facebook or Instagram or whatever, right? It does not stop you from doing any of that. It stops stuff coming in, not out. So anyway, that's it. Take this screenshot, I think. That's what I'm asking, right? Yep, that's it. If Windows is running and you got it shown up right here, take a screenshot of this, and you're good. You can even go in here to view, take screenshot, save that on the desktop or wherever you want it to be, and then look. Yay! I'll know it's a VM because you got this enterprise evaluation thing down here. Otherwise, screenshot is normal. I mean, the print screen button does function, so you can do that too. But all right, that's it. That's all I needed to show you. And somehow, I come in 15 minutes under the buzzer. Yay! Cool, well, that's it.